Welcome. I'm Amy Fitzgerald, Senior Marketing Manager for Consulting Engineers with Trane Commercial. And today, we're going to share with you some exciting information about the Consulting Specifying Engineer Magazine's Product of the Year Awards and 2 Trane Commercial award-winning solutions. This premier award program showcases new products in the HVAC, fire and life safety, electrical, and plumbing systems engineering markets, and is conducted annually by CSE. For 2023, we are pleased to announce our Trane Connected Service solution was awarded gold in the category of control systems, and our Ascend air-to-water heat pump Model ACX was awarded silver in the HVAC category. I'm so thrilled you have joined us. Let's listen along as I talk with 4 of our strategic product experts about these solutions and the overarching decarbonization and system benefits to you, our consulting engineer customers, and beyond. Hello, this is Amy Fitzgerald from Trane, and I'm talking with 4 of our subject matter experts on 2 of Trane's new award-winning solutions. First up, I have Todd Duncan, Trane's air-cooled chiller product manager, and applications engineer, Dan Gentry. Todd, I understand you have introduced the Ascend air-to-water heat pump to the commercial building market, but before we get deep into the product detail, I want to make sure folks listening understand the technology basics. So if you wouldn't mind, tell me, what is a heat pump and how does it work? And it pumps heat, right?
Yeah, you're correct. So heat pumps are fairly simple in concept. They're just a single piece of equipment that can either heat a space or cool a space. So a heat pump works by really just pulling heat from the air outside, and it uses that heat and transfers it to the building in colder months. These single pieces of equipment, these heat pumps, can then flow in a reverse cycle to cool a building in the warmer months. So the reversible process, which is the vapor compression process, is what heat pumps really rely on to both heat a building and cool a building.
Okay, so heat pumps can heat or cool by reversing their compression cycle. Is that how the Ascend ACX works? Or how would you best describe the Model ACX, Trane's Ascend air-to-water heat pump?
Yeah, the Model ACX is an air-to-water heat pump. And air-to-water heat pumps, again, are pretty simply an air-cooled chiller, a traditional air-cooled chiller that uses a reversing valve to operate in reverse. So take, for instance, in the summertime when we're cooling the building, cooling operation is the same as a traditional air-cooled chiller. We're extracting heat from the space of the building and transferring that heat energy to the outside ambient air. In heating operation in the wintertime, we reverse that operation, and now we're extracting heat from the outside ambient air and transferring that heat energy into the indoor space for heating the building. And so our Ascend Model ACX air-to-water heat pump, it's a package unit. It's available in nominal sizes for cooling of 140 to 230 tons. And then that same machine does about 1,500 to 2,500 MBH of heating in the winter.
Got it. And that sounds very cool. Or hot, I guess, depending on how you look at it.
Yes, depending on the season, climate, and the building needs. That's correct.
Excellent. Well, I am hearing a lot lately about the need for heat pumps like the new Ascend Model ACX and how they can actually help people electrify their buildings and also reduce carbon emissions. So how can the ACX help commercial building owners achieve their broader decarbonization goals?
Yeah, that's the really exciting part about this new product. The Ascend Model ACX heat pump can help building owners meet decarbonization goals, and it's both directly and indirectly reducing their CO2 equivalent emissions. So let's take the first one. The heat pump can directly reduce emissions on a job site by replacing on-site fossil fuel heating with an electric source of heating. They can also indirectly reduce CO2 emissions by being more energy efficient at heating than a traditional electric heating solution.
That's fantastic. Thanks, Todd. I definitely learned a lot about heat pumps. Dan, I think my next question is for you. Heat pumps are often used as part of a larger system that's designed to meet the needs of a specific building and their location or climate. So, what are some factors to consider when selecting the best electrified heating system for an application?
Yeah, so a location's climate zone is often a good starting point, as heat pump performance is highly dependent on ambient conditions. As the temperature drops, heat pump performance decreases as well, especially for air to water heat pumps. Ambient temperature and humidity also affect the need for defrost. The defrost cycle reverses the refrigeration cycle, applying heat to the outdoor coil to melt the frost that is built up on the coil when that has been detected.
That's interesting, Dan. Now, Todd, I know a lot goes into new product development. And how does the ACX address the ambient temperatures and defrost Dan was talking about? And are there any other key features that make this Ascend unit ideal for electrified systems and also overall sets the ACX heat pump apart from other products on the market today?
Yeah, thanks for that question. So I'll start out with that. This unit, this air to water heat pump, is really the first packaged, and when I say packaged, I mean non-modular air to water heat pump available in the North American market that is utilizing R454B as refrigerant. So Trane's comprehensive lab testing capabilities help to validate this unit's operation throughout the operating map. So whether we're in cooling mode on the hottest day or heating mode in the coldest day, the lab testing capabilities help prove this out. Not only that, but using that comprehensive lab testing capability allowed us to introduce some unique controls for defrost management and fan control. And I'll just give one example. When we were going through this testing, we identified that using separate expansion valves on this single unit, one dedicated for heating operation and one dedicated for cooling operation, really allowed for a much more robust unit operation, as well as improved efficiency during heating and during cooling.
Well, it sounds like you've figured out how to mitigate cold climate challenges and also optimize efficiency. So, assuming a building owner is now looking to incorporate a heat pump, how could engineers best incorporate the ACX or heat pumps more broadly into their system design, Dan?
Yeah, so applications that have heating or cooling equipment that's nearing the end of its life is a good place to look. It's important to look at the system holistically, though. Heat pumps, along with heat recovery and auxiliary heat, can be combined to provide a lot of value while also meeting the needs of the building. Our comprehensive chiller heater system provides guidance on how to apply heat pumps and other options for reliable, cost-effective, energy-efficient solutions to cool and heat facilities, while at the same time reducing carbon emissions. Trane can also help with heat pump sizing and controls, of course.
Is there anything additional to consider once the heat pump is operational? And how can engineers and building owners know their heat pump system is both right for today and also ready for tomorrow?
Sure, yeah. Heat pumps, like most HVAC equipment, use refrigerants, which can have harmful greenhouse gas effects. So proper management is very important, along with the selection of equipment that does have low global warming potential refrigerant or GWP.
Yeah, and I'd like to add to that. Just having continuous and proactive maintenance on the asset, the equipment is also important. And with the Model ACX, it's enabled by Trane's Symbio 800 unit controller. And the beauty of this is it can connect to any building automation system to provide 24/7 monitoring. This way you can know when the heat pump performance is less than optimal, and Trane's connected services solutions can even help predict if the heat pump is going to go down. So this helps to increase uptime, reliability, energy efficiency throughout the life of the of this asset. Providing energy savings while reducing total cost of ownership.
Fantastic. Well, thank you so much, Dan and Todd. I have learned a ton about heat pump capabilities today. let's now transition over to our next set of experts, Patrick Tonker, Trane's Director for Connected Building Services, and Susie Gornick, Director for Trane's Digital Product Management. Patrick, how would you explain Trane Connected Service?
Hey, thanks, Amy. Connected Services is a continuum of offerings that allows us to meet our customers where they are and focus on the outcomes that matter to them. Our first level is for customers who care more about maintenance outcomes at the equipment level, and we call it Connected Mechanical Services. In this offering, we bring to bear our digital platform to improve the way we provide mechanical services. Our second level, Connected Building Service, builds upon the first, bringing in system and building level analytics using our Trane Connect platform. And we use that to provide insights that help customers optimize their buildings. Our third level is what we call intelligent services, where our building experts partner directly with customers to drive comfort, energy savings, and sustainability outcomes through a consultative approach.
Okay, great. So we have multiple levels of connected service agreements. That must really help us get specific to exactly what our customers need. But I think we should dive in a little bit deeper. So what type of value could a building owner expect from having a connected service agreement?
Yeah, it's a great question, Amy. You think about our customers and our industry at large. We've got several challenges that we've been facing for a while, and they don't really seem to be going away. One is, and I know we feel it at Trane, our customers do as well, the demand for productivity, being asked to do more with less. It's there. And there's also this growing labor shortage of qualified technicians. We can't find enough qualified people to do the work. So this is where our connected services comes in, right? It helps us provide an enhanced level of service, allows us to more effectively use technician time, helping us address the labor shortage without sacrificing customer value. Our analytics also allow us to spot issues proactively, right? And we have visualization and reporting that provide proof to our customers on how their equipment and buildings and systems are performing. Our connected services also support customers and Trane's sustainability goals. So you've got equipment and systems and buildings that have extended life. They perform better over that life. They use less energy, which lowers carbon emissions. And we're using that technology that helps us better manage technician time, also allows us to only roll a truck when absolutely necessary.
Got you. Okay, so remote inspections sound great, but as a customer, I would think there's potential for those who've built a relationship with their current technician over the years and would maybe want the same technician performing their remote inspections. Is that a possibility?
Oh yeah, absolutely. That's how we've designed our connected mechanical services offering. The technicians that our customers rely on and trust and have for many years, they remain the primary conduit for information on how their equipment and systems are performing.
Okay, that's great. So with connected service, we are able to perform remote inspections and gather a ton of data around how the HVAC equipment is performing. Susie, what type of information will customers be able to access once they're connected?
Well, Amy, we have several reports that cater to the various needs of our customers. We have hundreds of analytics that help identify how the equipment and the control systems are running, and we collect over 5 billion data samples a day to identify that unexpected behavior that could contribute to the equipment's degradation over time or excessive energy use. So if we look at chillers specifically, we pull data that would impact the expected life of the equipment. For instance, if the compressor is short cycling or it's just continually running and then stopping and running and stopping, we'd want to call attention to that with our technicians on site to go ahead and address that. We also measure daily runtime to ensure that the chiller is operating within the temperature and pressure thresholds that we would expect. All of these factors contribute to life cycle tests that we run and the expected equipment life of the chillers. We also look at refrigerant systems. Sometimes we can detect leaks by measuring the daily purge or the differential pressures. And these analytics and several others are summarized for customers in our remote inspection reports. These reports supplement the on-site inspections that our technicians perform, and we can make them available as often as customers would like to see them.
What about building level analytics or analysis?
Yeah, so for building systems, we take a more holistic view by tracking energy use and load profiles of the building. This can be done in several ways. We use, oftentimes it's utility bills, but sometimes we can get our hands on utility interval data, or we might have energy meters that are installed on site. So with the utility bill data, we can plot historical energy use and costs over the course of time. Then we compare how the building is operating relative to other industry average buildings of that type and square footage to see how they stack up. This is called the energy use intensity journey and the energy cost index. Obviously, there's varying utility rates in different parts of the country, so those can factor into how the utility bill costs come into play. All this analysis establishes a baseline that helps us identify areas of opportunity for energy savings.
The EUI journey sounds like a great tool for building operators and engineers alike.
Yes, exactly. It's a great tool to aid our sales process. If customers have access to utility interval data, we can perform more sophisticated load profiles of the building. So interval data is just a little bit more refined because we're collecting it in 15-minute intervals rather than a single data point for the whole month. So the resolution is a lot better. And this allows us to analyze the best normal energy performance of that particular building. So we can compare that building to its best day or most energy efficient day. And from there, we can find different energy conservation measures that can further optimize the system.
And what about energy meters? You had mentioned that sometimes they're installed on site. How can they help?
Yeah, so with energy meters, we can track data nearly real time because we're collecting inputs every 15 minutes directly from the site. This provides more visibility for our customers to track their performance through dashboards and analysis tools, and they can see trends over time. So we have tools that track energy demand and consumption. And in some cases, the peak demand of a building could be really costly. It could set the utility rate for the following calendar year in some geographies. So tracking this and taking steps to prevent large peaks can assist customers in managing their energy costs. Consumption is often used to track trends over time. So we use that to baseline the building, and then we track the impact of the work that we've done through energy conservation measures just to see how it compares to the baseline that we started with. So energy meters do provide a nice refined look at the load profiles in buildings.
That's great to hear. Changing our perspective just slightly, many of our customers have either set ESG goals or they know they should be setting goals and creating a decarbonization plan, but they might not know where to actually get started. So how does a connected service offering support a building owner or engineer's decarbonization goals specifically?
Yeah, so energy savings of all kinds contribute to decarbonization. So anytime that we're working with our customers and the engineers that support our customers, we do try to use the tools that I've mentioned. But for decarbonization specifically, we've started by creating a baseline report. In order to establish this baseline, we use the same 12 months of historical utility bills, as well as the eGrid emission factor. And that helps us determine how clean the power generation is in each geography. Similar to the energy use intensity journey, we can track carbon emission reduction through electrification of heat or other energy optimization initiatives or renewable energy to help our customers. We also help customers track scope 1 and 2 emissions, and this baseline can be refreshed on a periodic basis to track progress over time.
It sounds like there are lots of complexities in this space, but that Trane is really here to help engineers and owners get started on their path to decarbonization.
Yes, exactly. We have lots of folks that specialize in decarbonization, and we're here to help.
Great to hear. Thank you so much, Susie, and thank you, Patrick, for joining me today. I definitely gained a better understanding of our connected service offerings and how engineers can best utilize this type of data to support their customers. Thank you. We hope you've gained a better understanding of the Ascend Model ACX, our Silver HVAC Award winner, and Trane Connected Service, our Gold Control Systems winner. There are many resources available on Trane.com to support your journey, including current and future project plans. And for more direct support, please reach out to your account manager in your local Trane office. Thanks for joining us.